The reciprocal of some quantity is 1 over that quantity. So for example, if we have a variable x, then the reciprocal of x is 1 over x. If we have the quantity x squared, then the reciprocal of x squared is 1 over x squared. We could go on. The reciprocal of any quantity is 1 over that quantity. But in this course we're going to be particularly interested in the graphs of these two reciprocal functions. The graphs of y is 1 over x and the graph of y is 1 over x squared. Let's start with the graph of y equals 1 over x. As usual, if we're dealing with a graph we've not seen before, let's just plot some points. We'll start by plotting the coordinates x, 1 over x, for some positive integer values of x starting from 1. Of course, if we have x equals 1, then 1 over x is 1 over 1, which is 1. So one of the points that we're interested in is 1, 1. For an x of 2, we will have a 1 over x of 1 over 2 of a half. And if we now consider the next few integer values of x, we will see that the value of y that goes with it is of course going to be smaller every time. Of course the value of y will never quite get down to 0, however large x is, but our points will be getting closer and closer to the x-axis as y gets closer and closer to 0. Now let's consider what happens as the value of x gets smaller and smaller, approaching 0 itself. Starting again with an x of 1, let's now decrease x to a half. Y will be 1 over a half. 1 divided by a half, that's 2. And in the same way, if we let the value of x get closer and closer to 0, the value of y will get larger and larger. We can now see the shape of the curve that can pass through these points. We can also consider what will happen for negative values of x. For example, if x is negative 1, the value of y will be 1 over negative 1, which is itself negative 1. And indeed, in every case, the values of y we get for negative values of x will be exactly the same as the values we get for the corresponding positive value of x, but also negative. So when considering negative values of x, the curve will look like this. It is important to realize that this curve will not be defined for an x value of 0. We cannot find a value of y that corresponds to 1 divided by 0, so the curve only exists for positive or negative values of x, but not for an x of 0. Also, because the curve gets closer and closer to the x-axis as x tends to positive or negative infinity, but will never quite touch it, the x-axis itself is an asymptote of this curve. Asymptote is the word for a line which a curve gets closer and closer to, but never quite touches. Similarly, if x gets closer and closer to 0, either approaching 0 from the positive or negative direction, the value of y gets larger and larger, so the curve approaches the y-axis. But once again it will never touch the y-axis, so the y-axis is also an asymptote of this curve. So let's consider these properties of y is 1 over x. Firstly, it is not defined when x is 0. It has asymptotes of x equals 0, the y-axis, and y equals 0, the x-axis. We'll now consider the graph of 1 over x squared. Again, a new unfamiliar curve. Let's try and work out what it looks like by plotting some points. If we have an x of 1, then 1 over x squared is 1 over 1 squared. That's 1 over 1. It is 1. So again, this curve will pass through 1, 1. If we were to consider an x value of 2, 1 over 2 squared, 1 over 4, is a quarter. And we can again see that as the value of x increases, the value of 1 over x squared decreases, so the curve will again approach the x-axis. However, the approach to the x-axis is far more rapid than it was with a 1 over x curve, so the shape will be slightly different. Let's again now consider what happens as x gets smaller and smaller as it approaches 0 from above. Starting at 1, we know the curve passes through 1, 1. If we had an x value of a half, 1 over a half squared, that's 1 over a quarter, that's 4. And if we continue to approach 0, the values of y will increase, and once again they will do this more rapidly than they did with a 1 over x curve. We can now see the shape of the curve that will pass through these points. Notice that there is a little less symmetry here. As the value of x increases, the curve approaches the x-axis very quickly. As the value of y increases in the same way, the curve doesn't approach the y-axis quite so quickly. We also have to consider what will happen for negative values of x. If we have an x of negative 1, then 1 over negative 1 squared, that's 1 over 1, that is 1. And similarly for any other negative value of x, once we square that value we will have a positive number, so the curve will be a mirror image of the positive value of x curve in the y-axis. Once again, both the x-axis and the y-axis are asymptotes of this curve. And also once again, the curve will not be defined for an x value of 0. So both of these properties of a y equals 1 over x curve are also true for a y equals 1 over x squared curve. Now, as well as these basic curves, we may have to work out how to sketch a curve such as y equals 4 over x. Well, our transformations work can help us here. We could rewrite this by dividing both sides by 4 as y over 4 is 1 over x. So you can see that if we started with a y equals 1 over x curve, which we now understand, how could we turn that into y over 4 is 1 over x? We have replaced y by y divided by 4, and our transformations work tells us that what we need to do is to stretch the original graph parallel to the y-axis with a scale factor of 4. So beginning with our normal 1 over x reciprocal curve, we can get the graph of y equals 4 over x by doing a scale factor 4 stretch. The green curve is our y equals 4 over x. For example, on the original curve we had the point 1, 1. Now that we have stretched by a scale factor of 4 parallel to the y-axis, that y-coordinate of 1 has been stretched up to a y-coordinate of 4. And similarly, on this side of the equation, we used to have a y-coordinate of negative 1 to go with an x of negative 1. Now we have a y-coordinate of negative 4. Everything has been stretched parallel to the y-axis while leaving the x-axis invariant. Suppose we wanted to know what the graph of y is negative 2 over x squared looks like. Well, we could rewrite that as negative y over 2 is 1 over x squared. So we could see how to start off with a graph of y equals 1 over x squared, which we understand, and turn it into the graph we want. And it's best to do this in two stages. If we first turn this into y over 2 is 1 over x squared, then we've replaced y by y over 2. If we then transform that into negative y over 2 is 1 over x squared, we have now replaced y by negative y. The first of these is a stretch parallel to the y-axis of scale factor 2, and the second is a reflection in the x-axis. So beginning with our 1 over x squared graph, we can do a stretch of scale factor 2 parallel to the y-axis, and we can now follow that with a reflection in the x-axis. Removing the original curve for clarity, here is our sketch of y equals negative 2 over x. Suppose we are asked to sketch the curve with equation y equals 1 over x plus 3. Well, we know what the curve with equation y equals 1 over x looks like. How could we get from that curve to the curve with equation y equals 1 over x plus 3? Well, the x in the first equation has been replaced by an x plus 3 in the second equation. And x plus 3 is the same thing as x subtract negative 3. So our transformation work tells us that what we need to do is the translation of negative 3, 0. So starting with our original curve, we need to translate 3 units to the left. Notice that as well as drawing the new curve shifted 3 units to the left, we've also shifted the asymptote, the y-axis asymptote, 3 units to the left. In fact, if I were trying to draw this freehand on paper, I would be more interested in drawing the asymptote before I drew the curve. If I know that the asymptotes of the new curve are still the x-axis and now the line x equals negative 3, it will be easier to draw our new curve around those two asymptotes. If we are now asked to sketch the curve with equation y equals 1 over x plus 3, how could we go from the curve that we know y equals 1 over x to the curve with equation y equals 1 over x plus 3? Well, this second curve could also be written as y subtract 3 is 1 over x. So our transformation work this time tells us that what we need to do is a translation of 0, 3. We need to move everything 3 units upwards. So once again, beginning with our original curve, we move everything 3 units upwards. Let's remove the original curve for clarity. Here is our sketch of y equals 1 over x plus 3. If I were drawing this freehand, I would begin by just drawing the translated asymptote. So I know that I have asymptotes of the y-axis and the line y equals 3 to draw my curve around. We may also be asked to find the intersection points of our new curves with the coordinate axes. We can see that in this case the new curve does intersect the x-axis. How can we find exactly where it does that? Well, an intersection with the x-axis is where y equals 0, so it's best to do this algebraically. If y is equal to 0 in our new curve, that means that 1 over x plus 3 is equal to 0, which therefore means that 1 over x is equal to negative 3, and so x itself is equal to negative 1 over 3. And so the point of intersection of our curve with the coordinate axes is negative 1 over 3, 0.